Okay, so we are talking about simplifying algebraic expressions. When we're talking about this, we're looking at different types of basically a expression. And an expression, if you remember, is a list of algebraic symbols that are broken into parts between addition and subtraction signs. So, for example, I might have something like 3x squared plus 8x minus 7. And this is an algebraic expression. Each one of these parts, the 3x squared, the 8x, and actually the negative 7, is actually what we call a term. Those are called terms. Move that down a little bit. Each term is broken up into two parts. Some terms are, I should say that. In this case, we have a number in front of the variable. This is called the coefficient. And then there's a variable. Now, when a term doesn't have a variable, it is called a constant. Now, a lot of times we talk about variable or terms, and when we talk about algebraic expressions, we say it's actually divided up by sums. And you kind of look at where the sum is on that last part. Well, there isn't one that you can see, but really there is, because a negative sign or subtraction is really plus negative. So this is really 8x plus negative 7, which is why the constant is negative 7. So I always say that the sign in front of a number always attaches itself to the number, so you know if it's positive or negative. In some cases, when we look at terms or an expression, we might have something like 3x plus 4y plus 8x minus 2y plus 9. When we look at this, in this particular case, we're talking about what the terms are, and we know the terms are going to be 3x, 4y, 8x, negative 2y, and 9. But some of these terms, like 3x and 8x, are what we call like terms. And like terms are terms that have exactly the same variable coefficients. There's another pair of like terms, which is 4y and negative 2y. And of course, then we have, obviously, the constant. Take a look at the following expression. Negative 4x plus 2y plus 3y plus 2x. Identify the like terms. Pause the recording and identify the like terms. If you did it correctly, you would have told me the like terms are negative 4x and 2x and 2y and 3y. Now, what happens in a expression is we never like to leave an expression just as is. We want to be able to simplify expressions. For example, 4x plus 6 plus 2x. Well, I see there are like terms, 4x and 2x. So I'm going to combine those together to be 6x plus 6. This is kind of like what we did with the menu math. Think that's 4 extra large sodas and 2 extra large sodas. Gives us 6 extra large sodas. Would you try this one for me? And I'm going to make this one a little bit on the tricky side. but let's see how you do. Pause the recording and simplify this for me. Okay, if you did this correctly, you would have started by distributing the negative 3 to get 6y minus 3x plus 6y. Remember, the negative sign in front of the 3 attaches itself that way, so you really want that, and that's why you get the negative 3x, and then it's a negative 3 times the negative 2, which is why I get the positive 6y. But I'm not done yet, because I notice that the 6y and the 6y are like terms. I can combine those together to get 12y minus 3x. Now, a lot of times people will say, oh, write it in alphabetical order. So you could have put negative 3x plus 12y. Why is it negative 3x plus 12y? The negative sign in front of the 3 attaches itself, so it goes with it, and the 12 was positive. Okay, I'd like you to try the following. I want you in each of these expressions, I want you to identify the terms, identify the like terms, the coefficients, the constants, and then simplify if you can. So we have 6x plus 2x plus 3. And then how about we do 4a minus 6 minus 2 times a minus 1. So again, I want to know I want you to simplify it first. So let's do simplified first. Then identify the terms. When you simplified, what were the like terms? What were in the simplified version, what are the coefficients? And what are the constants that you found? Do those. We'll go over those tomorrow in class.